So please mute your mic if you are having any doubt, so you can unmute your mic and ask the questions. Okay. So it is disturbing a lot. Please mute a mic. Please mute all of you the mics. If you are having any doubt, so you can unmute it and call back. Okay. So in the previous classes we have completed regarding the drill machines, as well as I have shown the demo in the our machine shop lab regarding the drill machines, lathe machines, okay, grinding machines and shaper machines. Now we'll go with the boring machine. Okay, I hope can everybody can see the screen. Anyone can reply? Can you see the screen? Huh? Okay. Okay. So boring machine, in the last class also we have discussed regarding the boring machine. Once again I will discuss, tell you in some brief what is a boring machine. So the boring machine is used to enlarge the previous hole. So see, whatever the these machines are specially used to make an holes. Okay. So which type of hole? Just suppose with the drill machine, if you have done a hole of 10 mm or 20 mm, okay, then you have to make that hole, or you have to extend that hole after up to 30, 40, 50 mm diameter. Okay, you have to increase that hole size. Okay, the diameter of the hole size is to be increased. So at this type of movements, these types of boring machines are used. So there will be the question rise in your mind, why the drilling machine is doing the hole. Okay, in 30, 40 mm, you can, by changing the drill bit, you can have the hole on the same drilling machine. Why the boring machine is required? Okay, why the hole is enlarged in the boring machine? So see, behind this there is a very important point, is that so the drill bit cost, okay, the tool which is used in a drill machine for making a hole, that is called as a drill bit. The cost of the drill bit is very higher, or you can say the price is very costly compared to the boring tool. Okay, so this is the first point. And second point is that the drill machines having its own limitations. Okay, maximum 0 to 40 mm, maximum 0 to 50 mm. According to that drilling machine, only the limited size of the holes can be made in the particular drilling machines. Okay, so there are so many different types of drilling machines are there, and different capacity drilling machines are there. Okay, according to that different capacity drilling machines, only that capacity of the holes can be done on that machines. Okay, for example, say if you are having a car, four-seater car, you can sit only four members in the car. Okay, if you are having a bus of 20 seats, so 20 people can sit in a bus. Okay, they can travel for a 10 kilometers, 20 kilometers, 50, 500, 400 kilometers. Same way in the car also, four members. More than four you cannot sit in the car, more than 20 cannot sit in the bus. Same way, okay, the drilling machines are also having the same problems, that the first of all, the drill bit cost, that is a tool which is used for making a hole, the cost of the tool is very higher. Okay, the wearing percentage of that tool, if you put an continuous use of that tool, if you are having a continuous hole on the workpiece by the same tool, the wear and tear percentage is more. Okay, by which the tool wears faster. Okay, this is the first thing. Second thing is that the capacity of the making a hole by the particular drill machine is then restricted or limited. Only this much hole can be done by the particular machine. Then next, when you want to increase the hole diameter or the size, so what you are going to do, that time these types of boring machines are being used for enlarging the hole which is done in the drilling machine, that is previous hole. Boring machine is used to enlarge previously drilled hole to the correct size, especially in large and heavy parts like pumps, turbine, railroad wheels. Railroad wheels means what? Track holes, okay, where the rollers have been used. Okay, in such type of wheels, these are been used. Okay, by means of a single point cutting tool. Only one single point cutting tool is there. Okay, have you seen the lathe machine where the single point cutting tool is there? Only one single point is there of that tool by which the boring operation is been done. Okay, the operation performed is preferred as an boring. Beside the enlarging and hole, a boring machine can also be used to perform operation like drilling. Okay, so this boring machine does the multiple operation. Now you can see over here which are the multiple operation. It can do the drilling, facing as well as milling operations. Okay, now let us see the classification of boring machines. So which are the boring machines? Are there different types of boring machines are classified? Okay, first one is an horizontal, second one is an vertical boring machine. In horizontal boring machines there are once again the different types are there, which are that table type, planar type, flow type, multiple head type. Okay, in second vertical boring machines, single column, double column. In third is a jig boring machine, and fourth one is an diamond fine boring machine, and fifth one is an CNC boring machine. So horizontal boring machine and the vertical boring machine. First, these are the two major differences. So what are the major differences? Why it is called as a horizontal and the vertical? So see, the axis of the boring machine. Axis means what? Whatever the workpiece you are going to hold in that one, that is going to rotate. Okay. Otherwise, the tool movement, the tool which is used for cutting the material, either it is moving in an horizontal axis. Okay, if it is moving in an horizontal axis, so it is called as an horizontal boring machine. If it is moving in a vertical direction, so it is called as an vertical boring machine. Let us see if there is a diagram. Okay, see, so this is a horizontal boring machine, you can see over here. So see, there is a center axis they have given. Okay, this axis is in a horizontal direction. Okay, now I will see the axis. See, this is the axis in a horizontal direction. Now here the workpiece is moving around this horizontal direction, as well as the tool is placed over here, it is also moving in horizontal direction. Okay, so these are the movements which are done in horizontal axis. Okay, so which is the axis? So this is an horizontal axis. You can see the dot line is there below, that is called as an horizontal axis. Okay, and now let us, I will show the vertical. Sorry. Now you can see this is a vertical boring machine. So see over here there are two columns I have given. Okay, this one column, two columns are there. Okay, so what is the direction of the head over here? Okay, from up and downward, this is in vertical direction. Okay, the tool is moving in a vertical direction and the workpiece is also moving in a vertical direction. Okay, there is no movement in the horizontal direction. So the movement of the tool or the spindle which is moving in an vertical axis, okay, you can see over here the vertical axis they have shown, okay, this way, these are the vertical axis. So the tool or the workpiece which is moving in a vertical direction, so that particular machine is called as an vertical slotting machine, boring machine, vertical planer machine, vertical drilling machine. Understood? And the horizontal, if the tool or the spindle which is moving in an horizontal direction or the horizontal axis, okay, called as an horizontal machines. Okay, so let us see constructional features of boring machine. This session construction features of boring machine, the table by the horizontal. So we'll see the construction features of the boring machines. Okay, the table by the horizontal table type, that is an horizontal boring machine, vertical main column boring machine, and headstock boring machine. Horizontal spindle, okay, work table, saddle, bed, and end support column. So these are the different parts of the boring machines. Okay, now we are going to study. Okay, in the diagram I will show you what is a vertical and a boring spindle machine. So see the table, this is a table type boring machine in which you can see the slider is there. Okay, see, this is a slider is there. Over here there is a table is there. Now this is what the spindle, which is the rotating spindle which rotates, and this is what the headstock is. What do you mean by the headstock? In the previous class, in the workshop with the video, I have shown the lathe machine headstock. How does the headstock works? Okay, over here there is an gearbox is there. Okay, by which the gears the power is transmitted. That gear is been connected to the shaft for the electrical motor shaft by the means of belt drive. Okay, the belt pulley is there. When the electrical motor rotates with the help of the powers, okay, that power is transmitted by the means of belt to the headstock. Okay, where there are the gears are being arranged in their appropriate ratios. Okay, that gears transmit the power to the headstock. Okay, the total assembly is called as an headstock, and which allows the spindle to rotate in an appropriate rpm, revolution per minute, or the speed you can say. Okay, as the spindle rotates, the spindle carries the job means what, in a workpiece, okay, in which you are going to enlarge the hole. That workpiece is being held in the spindle by the means of jigs or fixture or a small check. Okay, that workpiece has been hold. Okay, then that workpiece starts to rotate as per the speed of the spindle. Okay, and over here you can see the wheel is given for the for the positioning in an upper side or the backward forward side of the headstock. Okay, now here is the table. Okay, the workpiece is an heavy. So see, there are two different phenomena are there. Okay, if the workpiece is heavy, the over here the workpiece can become in stationary. Okay, or the tool can rotate. If the tool is in smaller size or an appropriate size, so the workpiece is been hold in an headstock, and on the table the tool is been placed for the boring purposes. Okay, so this is how sorry, so this is how the small operational okay of the horizontal boring machine. Okay, I hope you have understand. So see, once again I will tell you, in the headstock the workpiece may be hold or tool may be hold. Okay, there are two possibilities on the two conditions. Okay, first, if the workpiece is small, the workpiece can be hold in the headstock by the clamping device. Clamping means what? A holding device of the workpiece, that is called as a check, or any appropriate jigs and fixtures prepared for holding that workpiece. Okay, if the workpiece size is larger, so that workpiece is kept on this table and the tool is been placed in the spindle. So see, I will show you that. Just suppose this is an workpiece. Okay, you have to put an hole over here. Okay, so the size of this workpiece is very big, so it is placed on the table. Okay, and the tool is placed over here in the headstock. Now this tool is rotating one. See, this tool is rotating, but this workpiece is stable. Okay, now if the workpiece is smaller one, so the workpiece is been hold over here. Okay, then the tool is been placed over here. Okay, or this side you can take the, so this tool inserted in this one and make the hole. So these are the two possibilities of the operation that can be carried out in the horizontal boring machine. Okay, now let us see the construction features of vertical boring machine. So see, this machine is called as a double column or standard vertical boring machine. Why it is called as a double column? So see, you can see over here. See over here, there are two columns they have given. Okay, on these columns are nothing but the pillar on which the vertical movement. Okay, in upside and downside, the vertical axis movement. Okay, so these are the axis. The vertical axis movement of the tool head is been carried out by the help of these two columns. Okay, so at the center there are the two tools are been there, and over here the table is there. Okay, now let us see how the operation is been carried out in this vertical boring machine. So see, just take on square box that is an workpiece which is placed on this table. Okay, now you can see over here, this is a table. On this table the square box has been placed. Now over here you are going to hole two larger hole you are going to produce over here. Okay, and this tool, okay, the hole you have to produce, and over here are the cutting tools. Okay, one, two. Okay, so this is the cutting tool. The workpiece has been placed. Now by the help of the hand wheel, the movement of the tool head, the movement of the tool head is been done. Okay, the tool is been make allowed to touch the workpiece, then whatever the depth or the feed or the cutting dimensions are there, whatever you want to give, that has been given. Okay, when this cutting feed and depth has been given, then the tool you can see over here comes in downward direction and rotates in circular direction. Okay, in okay, vertical direction the tool movement is there in upward and downward. So upward and downward vertical direction the tool is moving, as well as it is rotating over here and makes the hole on the workpiece. So this is how the vertical boring machine works. Okay, why it is called as a double column boring machine. So over here there are the two columns are there. At the center there is a tool head is been given. That is why it is called a vertical boring machine. I hope students you have understood this one. So how does it works and what is the difference between the horizontal and vertical boring machine. Next machine, let us see. So see specification of the vertical boring machine. Okay, what do you mean by the specifications of boring machine? So see each and every machine having its own specification. For example, in the previous class also I have tried to explain regarding the sorry, regarding the specifications of the machine. So see each and every machines, okay, having their own specification. So okay, Vijay highlighted it, sorry. Okay. So the vertical boring machine is specified by one or more following criteria. So see for example, there are so many motorcycles. So you are using an bikes, okay, motorcycle bikes. Hmm? So there are so many different varieties, companies, bikes are there. Yamaha, Hero, Honda, okay. Then any TVS, okay, Bajaj. So there are so many different companies bikes are there. Each model having its own specification means what? The tire size are different. The engine capacity is different. Suspension capacity, the load taking capacity is different. Single seated bikes are there, double seated bikes are there, tri seated bikes are there, three seater bikes are there. Okay, so four-wheeler bikes are there, three-wheeler bikes are there for the handicapped peoples, two-wheeler bikes are there. Okay, so different specifications are there of that particular bike. Okay, 4 liter fuel tank, 5 liter fuel tank, 10 liter fuel tank. Okay, 125 cc, 360 cc, 460 cc. Okay, so each and every bikes or the cars having their own specification. Same way the machines which are used are also having their own, sorry, the machines which are using are also having their own specifications particular. Okay, so what are the specifications? So see the maximum turning diameter of the work table diameter, speed range of the work table, maximum weight of the work that can be accommodate or work table, maximum working height of the workpiece. So see uh, actually how to identify this, which are the specification are to be identified, they have given. Okay, so see when you going to select a boring machine or you are going to purchase any machine. For example, once again we will go for the bike. If you are going to select a bike, so what you are going to see in that? Okay, what you are going to see, how much cc it is. Okay, how much diameter this one alloys are there, wheel alloys are there, how much number of tires, that is the tire size is there, it is with there, seat capacity, average capacity, fuel average, how much fuel average is giving. Okay, so what is the weight of the bike, it is a lightweight or heavy weight. Okay, so these are the specification you are going to see before purchasing the bike. Same way, before going for the machining operation, you are going to see the specification, particular important specification of okay, important specification of this vertical boring machine. So which are the specification you are going to check for the vertical boring machine? So see, this is the first one: maximum diameter of the work, maximum diameter, turning diameter of the work. So see, what do you mean by maximum turning uh, diameter of the work? That in this machine, maximum limit how much diameter of the hole that can be produced by that machine, or you can produce by using that machine. Okay, that you are going to see. Okay, 0 to 100 mm, 0 to 200 mm, 0 to 400 mm. Okay, so maximum how much diameter that machine can produce an hole. So this is what the important specification that you are going to check before selecting the machine for the operation. Okay, work table diameter. So what do you mean by the work table diameter? So see, I will show you. So see the diameter. So see over here, there is an work table is there. So this is what the work table. This is what the work table. So the diameter of that particular work table. That means what? Why it has to be seen? So how much big size workpiece can be kept on that one? Okay, so the diameter is of 400 square feet. So if you brought an 800 square feet, okay, 800 square feet, how it is be like this way: 8 length into breadth into height, 800 square feet. If you brought such a size workpiece which cannot be sit on that table, or it cannot be hold on that table, okay, so it is no use, no operation can be done on that vertical boring machine. So the capacity of the table, maximum how much size of the workpiece can be kept on that table, that you are going to see. Okay, that is a very important part while selecting the boring machine. Now next, you will see the speed range. So this is what the speed range of the work table. So this, what is the speed range of the work table? As the tool moves, okay, has once the tool moves, the table of the workpiece, sorry, the table of the machine is also going to move over there. See, over here you have seen, this is a movement of the table is there. See, this is a table which is moving with the workpiece. See, suppose this is an workpiece which is moving in an forward, backward direction, left side and the right side. Okay, this workpiece is kept on this table. Okay, and this table movement is been done in a left side, forward direction, backward direction, as per the tool head. Okay, so that speed, by taking the workpiece load, and what speed does the table movement is being done. Okay, that is also you have to see. So this is one of the important specification. Okay, so the maximum weight of the work that can be accommodated on the work table, maximum weight of the work. So what do you mean by the work is nothing but the workpiece, whatever the metal workpiece, plastic workpiece, the job on which you are going to put an hole or produce an hole, that is called as an work. So how much maximum weight? 1 ton, 2 ton, 3 ton, 500 kg, 200 kg, 300, 400, or 50 kg, 20 kg, how much kg of the workpiece that can be placed on the work table, that you are going to understand and study over here. Okay, the next, maximum working height of the workpiece, maximum working height of the workpiece. So see over here on this table, how much weight of the workpiece you can kept, 200, 300. So this table can have the weight tolerance, can hold that workpiece. Okay, then next, so see over here there is an height difference. If it is going beyond this column, the head will be removed out. Okay, the head will be come out. So it is the maximum limit is there. Okay, from this portion to this portion, there is a particular height is been there for each and every machine, 5 feet, 5, 6. Okay, it may be 3, 2, 1 feet. Okay, difference is there and at that difference only the workpiece will can placed inside this uh, table or the between the head. Okay, if the workpiece is beyond the size, so what will happen, the tool will remove out. Okay, if the workpiece is beyond the size, what will happen, the tool should come over here at the up. Okay, outside the column, so tool may be come out. For that reason, the whatever the size is there, at that size, particular size, the workpiece is been hold. So this is also one of the important specification of the vertical boring machine for holding the workpiece. Okay, so this is the particular size workpiece, so it can be hold in a particular area. Workpiece can be hold. So this is what the simple specification of vertical boring machine, and these are the some of the milling machines. So in the next class we'll go with the milling machine. Now grinding machine is there. In the last videos I have shown regarding the grinding machine. Okay, in the next class we'll start with the grinding machine. Then at the last I will go with the uh, milling machine. After grinding there is a broaching machine is there, planer is there, shaper machines are there. We'll complete this all machines. That the last moment we'll go with the milling machines, because the milling machine is slightly some problems are there. Okay, it takes time, 1 or 2 classes it requires. So first of all we'll go with the broaching machine, shaper, planer and the grinding machine, then we will go for the milling machine. So anybody having any doubts? Okay, if you are having any doubts you can comments here. Anybody having any doubts? Ajit, so today's strength is very good. Okay, keep regular attending the class. See, if you are missing the class, it is very difficult to all to understand the classes. Okay, I hope you are understanding. I hope you are understanding whatever I am trying to explain you all. Is there any problem? Okay, anyone can reply. Okay, if you are having any doubt you can reply it. So see, hello.